Hi all, today's topic is all about using rotoscoping. And what is actually rotoscoping? We're going to be using a tool called Rotor Node in Nuke today, and we're going to go from a really basic masking to quite advanced, where we're going to be start looking at how we can create a rotoscope and animate that and then track it as well. So hopefully by the end of this week you will have a very fair understanding of what rotoscoping is all about. So here is a bit of a background. So this role is very focused on producing a high quality of rotoscoping masks for compositing artists to use, or on using specific digital paint tools. So you'll be, for example, we'll be using the rotor paint on Nuke on a sequence or an image to remove unwanted object or clean up artifact generated as part of the compositing process. Um, all in all, really, rotoscoping is short of technique in which you follow the outline and movement of an object to extract it from the shot. And normally, these tools are called like the splines tool, which generates a mat that you can use to extract the objects from a scene. Rotoscoping is probably the most time consuming in the visual effects industry, but it's the most important one as well. So if you're looking for a job in the visual effects industry, they would be asking you if you know how to do roto or roto paint. The most three important skills as a visual effects artist you'll need to understand to become quite proficient in rotoscoping, uh, match moving, and motion tracking. Um, and if I show you an example of the softwares, an external softwares, um, such as Silhouette does rotoscoping as well. Really good software, a piece of software. It's industry standard as well. We'll be doing a very similar thing in Nuke, but if you ever um, are working in industry, and it's a very well known package to really understand as well. And obviously, then you take the tracking data of this to Nuke or other compositing software. Another software which is quite a good one is Mocha Pro as well, especially used for the planar tracker. Again, you're going to be using planar tracker in Nuke as well. So you'll be kind of experiencing both the rotor paint node, rotor node, and tracking as well within Nuke. But this is just to give you an information that there are other softwares as well out there. So rotoscope allows you very accurately modify frames of a sequence or animation on the frame by frame accurate basis. So you can precisely follow the motion of an object in a frame or a sequence as whole. So tracking data is obtained, everything from attaching to 2D or 3D objects, and stabilize and destabilize the image to rotoscoping, paint, or cloning. So back in old days, the silly animation in which artists were who wanted to create lifelike motion to animation characters would use machines called rotoscoping. So from the olden days of silly animation, from the olden days, from old days of silly animation in so in the early centuries, people who wanted to create roto paint manually, people who wanted to create lifelike motion to animation characters would use a machine called rotoscope, which projected the film image into an animated plate. So animator would then trace, draw, or paint over the image into the glass. This process became known as rotoscoping. The job of roto paint frame by frame became roto paint. So as you can see here on this part where that was the camera here, and the obviously the light was coming through, and then it was projected on this glass screen where this gentleman is trying to sketch it out. So every time he's obviously creating roto paint frame by frame. And here is a kind of a digital roto where, if you see here, that's a bad roto. Do not use one big shape like this. So basically, this is an example of a roto. Now you must be thinking, hang on, when we were doing Photoshop, we did shapes like that, but that was static image. So you can create roto shapes when it's a static JPEG or TIFF or Photoshop image like that. But when you're looking at a real-time footage, which is a footage where you're going to animate, where the fingers are going to be moving, and as you can see very clearly that obviously there's a head movement there, and then obviously one would say that they want to mask out the hair to obviously retain the hairlines and stuff, where here as well, where you can see the neck is separate, the nose is separate, the head is separate, the shoulders are separate, and then you can see detailed fingers are separated as well. So that's like a really professional way of breaking shapes into small shapes, and this can be articulated as whole kind of shape as well. So then you combine them, then you can merge all the roto shapes together. Okay, so let's look at the roto paint node. Okay, so let's look at the roto node. You just press O on the keyboard. So roto shapes, paint, film gain, lens flare. So this is basically all in the roto paint kind of menu there. Hopefully you've seen the first week of the introductory, and here basically just wanted to break down so what really a Bezier is, what's a cast Bezier, what's a B-spline. So basically we can go through all that. So a lot of the artists, they actually use Bezier, and Bezier are the shapes you can define by using Bezier handles, and these handles are very good. So you can define different shapes by using handles and stuff. Hopefully we're going to practically work on that. Then you got your cusp Bezier where it's all kind of straight edges to it. Then you got your B-spline. Shapes are defined using points with variable tension. So basically, again, especially with if you are kind of doing a roto on a hand, this is quite a good tool to work with. And then of course creating a circle or shapes for Bezier, again rectangular, again create a rectangular shape, Bezier by cusp corners and stuff. So very self-explanatory. It'd be nice if you can experiment on that. Please look at the videos which we've produced, and it'd be nice to just kind of experiment with it, and obviously when you do mistakes then you can learn how it works as well. This one lets you draw the curve similar way like other shapes, except that it doesn't need to form a close shape. So basically all these shapes we have to really close it at the end, but this one doesn't close. So again, a shot of rotoscope is a technique in which you follow the outline and the motion of an object to extract typically it's called the spline, which makes a mat that you can use to make an object. So this is what I was trying to say about the open spline, where you can kind of literally go in, and then obviously it's all covered as well. That's just an example as well. Okay, so some hotkeys as well. So if you press on the Z key, make triangle handles horizontal on selection points, getting that smooth. So if you do Shift Z, it just retains it back to where straight cuts to in images. And then you've got your control and drag, make selection points, and these are all experimental for you to work with. So hopefully when you look at the videos, I'll be going through all that just to kind of give you a very better understanding, but just to have a kind of a note as well for you to just work with. um, Again, drawing and editing shape, pressing the P key to create another rotopaint node. And if you see the transfer of a group, so basically when you have a node there, and hopefully you've seen the video on this as well, where you select the node and then you can kind of transfer the group, like that individual part can be transferred as well. Again, a high feather setting with low feather fall off settings, so you can have all settings as well. You can bring in your tool in, and then you can drag your feather settings off and on. Again, pull out the soft edge by holding, so you've got this kind of tool which is really good, so where you can just literally bring out your tool handles in and out, which are quite good, especially if you've got feather. Okay, so let's look at what is 2D tracking. So 2D tracking is basically a group of pixels around from frame to frame are gathered through. Um, okay, so what is 2D tracking? So 2D tracking means following a group of pixels around from frame to frame and gathering through the location on each frame. So basically, you can use 2D tracking for either stabilizing the footage or batch moving the footage as well. So that's what the main purpose of 2D tracking is. There are 1 point, 2 point, 3 points, and 4 points. So let's look at that. So you can track up to 4 distinct features or pattern with each tracker node in Nuke. So how do we decide actually whether to use 1 track, 2 track, um, or more features? So it depends on actually what you want to do with the data and the level of accuracy you want as a result. And hopefully we will be going through when we are tracking to create really accurate shapes for rotoscoping. That's where we're going to start using the tracking data, and it depends if you can use 1 track or 2 tracks and stuff. And as you can see here on your right, with the you got your 1 track with X and Y position only. Then you got 2 tracks, you got X, Y, and Z. The rotation comes in, and then you got your 3 tracks. You got your X, Y, Z rotation and scale as well. So it depends on how you are tracking your footage. So 1 point tracking is a feature which is horizontal with with x's, and the vertical are y's. So the position with a little more perspective change on an image. So basically, this 1 point tracker is mainly used to stabilize the footage or just a really perspective view. When it comes to the 2D point tracking, you're looking at a position where it's where you've got a little bit of rotation with clockwise or um, or, or counterwise. So so when you are looking at that, so then the rotation comes in place as well. So in the same case, 2D tracking point is sufficient to calculate the scales, scaling of the feature as well. With 3D tracking is mainly for, it depends on the benefit of 2D points. So when you see that the 2D tracking is not really getting the right kind of the trackers are not really stuck to the actual pixels, that's where the third tracker comes in place, and maybe that's the image is rotating or scaling, and that depends on that. Where it comes to the 4-point tracking, which is mainly used for corner pins as well, as you can see in the picture here, where it's kind of featured, and that's why 4-point tracking is typically used for a corner pin tracking, and hopefully um, you will be learning that hopefully in a few weeks' time. Okay, and here is a typical example of tracking where you can see that you got your pixel here, and then you got your box, and you're really kind of searching the area. Right, that's the end of our lecture. So hopefully you've understood how rotoscoping works, and you've seen some of the videos, which are the introductory videos, that will give you a better understanding. The more experiments you do, the more you actually do some rotor, that will be really good as well. And these are the books, quite useful information. Again, you can go on the foundry.com as well. Really good video tutorials, really good reference files. And if you are stuck, please give us a shout. We're here to help you. Hope you've enjoyed this session, and please give us a shout if there's anything we can do. Thank you.